So hello everyone, my name is Abhi and I will be taking your session on SD-WAN technology. We'll understand what basically SD-WAN is. So first of all, SD-WAN, where it stands for software defined or where defined wide area network, right? So as I discussed, we need to understand first what is your legacy network and why we have moved from legacy network to the SD-WAN, right? First thing. And then the second thing, that's okay. We are understanding here the WAN from the WAN perspective. Do we have any other technology that is basically covered for the LAN and even for the data center as well, right? So we'll come to particular that topic soon, but let's understand first what is basically the legacy network. So if you talk about the traditional, let's say this is basically a your WAN connection. Normally WAN connection, when you take it, either you would take it from the like MPLS or the internet, right? So this is, let's say, internet, and this particular network is WAN. Whenever we say WAN means MPLS, because here you don't have to worry about the security, because your traffic is being encapsulated using the labels, right, where it is already secure. But on top of that, we have IPsec VPN that you can implement to have an even more granular approach, more secure approach, right? So WAN and internet, or maybe this ISP, these are the two providers, or these are the two services, or the in legacy network that we normally use, and we always prefer to go from, let's say this is your gateway, so we always prefer to send the traffic from your WAN, because it is considered as a more secure. Internet is very less secure, and that is the reason in real world, whenever we take the connection from internet, what we do actually is we deploy over here a firewall. But you might have never seen the firewall being implemented over the WAN connection, over the MPLS connection, right? So your all traffic which is basically coming through the internet will hit the firewall do its job, and then send it to the gateway, and then gateway will distribute it further. Isn't it? So this is what basically happens in legacy. Now, since as I mentioned, this is your primary connection, right? All the traffic or the branch office traffic is going through the WAN connection. This basically is for the kind of a backup for the internet, right? But through the internet you can't reach the WAN to your branch office. This internet is only for the internet public access for the services, right? So only way to reach these branch locations, let's say one is in Arizona, one is in Tokyo, one is in Sydney, right? These branch locations, you can only way there is only way to reach through the WAN, not through the internet. And even in actual network, if this user also wants to access the internet, consider that this is your head office, headquarter. This particular branch is your headquarter over here, right? And these users, if they want to access internet, you will not deploy internet connection everywhere in your branch offices. Why? The first reason, since it is not secure, and you have to deploy the whole security solution like firewalls, like IPS, like other security products, which is going to be very expensive. It's not about only the product, but you would be needing the support team also, you would be needing this implementation team. So in nutshell, it is going to be very expensive. So what we do, all the branch offices will come to the headquarter, and from headquarter they will go to the internet for the internet access. because this path is already secured because we have the security solution in place. Make sense? So here we are using this for the branch communication. More the number of branches that you have, right? The more traffic that you have, sending it through the MPLS. And this is where obviously you have to plan as in redundancy, not relying on particular, one homed, but you will have multi-homed, dual or dual home technology kind of topology, where you are basically deploying, multiple connections towards WAN. One might act as in primary, the other might act as in secondary, or maybe load balancing or anything. But even here also, if I have two MPLS connection towards this WAN, this would be primary and this would be secondary, let's say, and this is kind of a bucket for the internet, right? So in order to do the load balance here, even this primary and secondary, we have there are routing, efficiency. We have routing capabilities where they can do the load balance, but these policies are very complex. Let's say policy based routing you have, where you can send the traffic, half of the traffic you can send it over here, and half of over here, but these are very processor intensive, right? So you have to plan accordingly as in which device that you have to deploy here. So overall, that solution, we can achieve the load balance, to the WAN connection, but the point is, it is going to be very tedious. It's not an easy job, right? So in networking, everything we can do. It's not like here and from here and there, right? Putting extra effort, we can do that. But the point is whether it is scalable or not from the business perspective. The businesses where they are highly kind of demanding, the business where they are highly secure, their resources have to be available 24/7. From those business perspective, these solutions are not enough. Do you agree? Raise your hand if you have any question. Right, so that's basically the traditional what we are talking about. We have seen the challenges here. Challenges: this internet, we are not using it for the communication, branch communication. This WAN, we are using only one connection as a primary and the other connection as a secondary, right? And on top of that, you have to have a lot of resources for the configuration, for the implementation, right? So there is no proper control. When we say proper control, means if you want to make some changes in device A, you have to log into this device and make the change, save the configuration, exit out. On this device, access this device maybe through console, through SSH, right? Configure it, save the config, exit it out. So that way, the whole day is gone. And even the engineers, the resources would be busy on making those kind of changes, because network is all about making necessary changes here and there. Today we have this requirement, okay, implement this. Tomorrow we have this requirement, okay, implement this. So it's all about day-to-day kind of activity. So we need a lot of resources as well to make the changes like this. And on the other hand, are these changes granular? Are these changes accurate? I would say no. Human error, right? We might have seen in our production also, we might have seen a lot of examples where we do some misconfiguration, isn't it? This engineer has configured this, which is not supposed to be there, or this engineer has missed this to configure. So a lot of configuration, like wrong configuration or configuration missing, a lot of kind of scenarios we see day to day. So all those challenges are there in legacy network, in your WAN. This is what we address in software defined WAN. This is what we address here. All the challenges what we have discussed, whether it is from the resources perspective, whether it is from the expenses wise, the effort wise, time wise, and the granular approach. How ease the traffic can be. That's what basically we're trying to solve it here in SD-WAN, right? All right. So that's something we have already discussed. The normal approach, how the users access the internet. They basically, their approach is the traffic would go to the branch gateway. From branch gateway, it will exit out towards the WAN MPLS connection, and it'll go to the data center, right? Data center usually we deployed in head office, headquarter, and then from data center, it'll go to the internet. That is the legacy approach. Now, when we change to SD-WAN, you have two approaches here. Okay, do you see any advantage over here in this approach? Guys, a question here for you. Do you see any advantage with this approach? Yes, no, maybe.
Yeah.
Advantages.
Yeah. Do you see in this flow, do you see anywhere the advantage?
Uh, it will verify each and every packets that WAN flow.
Okay,
Hello.
perfect. So that's correct. The user traffic is being monitored at this particular place.
Yeah.
Every branch users traffic can be monitored here in data center. That's the only advantage I see. Otherwise, rest all are disadvantages. Like the resources are being unnecessarily consumed. If we bypass this data center, we can utilize it more, right? So when we say monitoring in your, then you might have a business, a nature of business where you need kind of a strong monitoring of the packet, strong monitoring of your user traffic, which is going towards the internet in and out. So this basically option is still there, and that is the reason this option is still there in the SD-WAN if you want. But every company won't be doing that, isn't it? I would say 80% companies would want to get rid of this kind of connection and let the user go directly to the internet rather sending into the data center and then internet. This is where we have two approach here. The user traffic, it will go to the branch gateway. From branch gateway, how you configure that again depends. If you want the traffic to send it to the MPLS through MPLS and data center, right, and then internet, that is also possible. Okay, but if you don't want this kind of approach, which is this one actually, if you don't want this approach, then the user traffic will go to the branch gateway. From branch gateway, it will exit out towards the internet and will go directly to the internet. Right? So it is again nature of business whether you want to opt this or opt this, but you have now that option available. You have that scalability. Not only this, but even you want software services you want to access, right? So you have option through the data center or direct to particular, uh, SaaS, multi-cloud, whether you want to go to the multi-cloud through the data center or you want to go directly. So you have that option here in SD-WAN, right? These are the challenges basically we discussed in the legacy architecture, right? Expensive because you would be needing the resources, technical support, and etc. Difficult to support because device configurations, complex management, right? Slow truck, it's time consuming, whatever change that you want to make. And static network, it is not that flexible, right? Poorly integrated, as I told you, conflict in policies, conflict in configurations, and risk as well from accidental interactions and vulnerabilities, right? This connectivity centric, if you talk about the incomplete user experience, right? Incomplete user experience, because every time you have to connect to the device individually one by one and make the changes. So these are something that we have already discussed in just now. Yeah.
Yeah, yeah.
All right. So before that, here itself, I want to discuss one more thing. Okay, so a little bit we have understood SD-WAN. I mean, what exactly it does, what we are trying to achieve here, right? So we have, so far we have talked about wide area network, isn't it? So far we have talked about the WAN. So for WAN we have SD-WAN, but can we use SD-WAN for the LAN also? If I have a LAN part, right? Can we use SD-WAN for the LAN? I would say no. And when we say LAN, means the switches. We have, let's say, hundreds of switches, thousands of switches, right, in our network. I have seen a companies where they have like, thousands of branches. Each branch they have some hundreds or the 500s approx like switches. A very huge network. So in that case, what about the LAN solution, right? So you might have
Uh,
heard about SDXs. Yep.
SDXs. But what about like ACI, Cisco ACI?
Yep. Coming to that,
It's okay.
right?
It seems
Eh,
like SD access.
it's like SDXs, but for that ACI is another component of the similar component like SD-WAN or similar technology that like SD-WAN. See, ACI is specifically for the data center, right? So this is WAN, this is LAN, and for the data center, what technology we have is ACI. I was talking about the head offices, right? So there we have that ACI concept. Okay, the job of these three technologies are same, pretty much same. Centralized monitoring, centralized configuration, right? Better experience. This is what actually they try to achieve here. All three technologies are trying to achieve the same, but this is basically for WAN. This is basically for the data center, and this is basically for the LAN. LAN as so when we say data center for, I mean, SDX is for the LAN, means your access point, wireless controller, right? And as well as switches. Yep, makes sense. Perfect.
Yes.
So now let's get in more into the SD-WAN and understand what basically the architect, how that architecture looks like, what are the components of SD-WAN, and what they do, where do we fit them, and etc. So when we talk about the architecture, SD-WAN is, I mean, these are the main four components of it in this architecture, right? And that's it. So if you have understood all those four, means you have understood the, like, 50-60% you have understood the SD-WAN, right? So this basically orchestration, or we call it V-bond, right? Uh, this also called from Cisco language, it is called plug and play. And what basically this does, we will discuss in detail, but I'm just giving you the overview here. What basically this does is for the initial setup and security. So when we say security, I want to make sure all the devices which we are adding in basically SD-WAN are authenticated. So AAA, I would say rather, right? This is the major responsibility of B-bound. Where do we see this B-bound? B-bound sits always in the internet. It would have internet access, right? And that's where I told you this the Cisco plug and play. So we'll talk about the deployment also. What all the deployments can we have in on-premises also? Yes, we can have, but we'll discuss this later. So you got my point. V-bond, what it does? It provides a security, right? Next, we have the management. For the management, we call it vManage. This vManage, as you see here, multi-tenant or dedicated, means it can be for one customer or it can be for multiple customer. We have that option to create the multi-tenant, in particular that vManage. So vManage can be shared. That's what it is trying to say, right? What it does, a most important part of the SD-WAN architecture. Almost, though all the components are really important, but this vManage does a lot in terms of implementation. It does monitoring. It does, we can perform here troubleshooting. We can monitor. We can also, configure, like implementation. This is where it is called zero day zero, starts with the day zero, means designing, implementation, troubleshooting, monitoring, everything you would do in this vManage. How does it look like? It looks like this. This is a symbol. Yeah. And then analytics is kind of again licensed based. That's basically for mainly used for the analytics. So we'll discuss that also. And then we have vSmart. Okay, you see here the control plane and data plane, isn't it? Control plane and data plane. So we all understand what is control plane and what is data plane, right? So earlier in legacy, this control plane and data plane used to, legacy is still there. So let's not use used to, but the control plane and data plane both sit in particular one device in legacy network, in legacy WAN. But in SD-WAN, we have segregated that control plane separately and data plane separately. So the vSmart acts here as a control plane. What is the job of control plane? Prefix advertisement, learning the prefixes, building the table for the next hop advertisement, isn't it? That all happens in the control plane. So who does that now, that job? The vSmart does that job. And this is how it looks like. That's a symbol of Cisco vSmart. By the way, V stands for Veptela. Okay. And then we have data plane, and the data plane is only data plane primarily it is used for forwarding the traffic. All right, I know that. Forwarding the traffic. And that's why basically we have in data plane, you can deploy VH, which is Viptela. We have CH, which is Cisco. And then Cisco ISR, ASR, ENCI, and white box can be deployed, or it supports as an VH here, edge data plane. And this is basically for the traffic forwarding. That's how basically we it looks like. All right, so let's get into one by one now. Let's understand the component by component. vBond is SD-WAN orchestrator, right? What it does basically, as I mentioned before, it orchestrates connectivity between management. Management means we manage, control panel, which means vSmart, and data plane means vEdge. So this vBond establishes the connection between data, uh, data plane, control plane, and the vSmart. How it does? What basically it does? So we are going to install uh, this ZTP stands for zero touch provisioning. So sometimes you might hear zero touch provisioning. Sometimes this PNP is Cisco basically nomenclature, and ZTP is kind of, I would say the other vendor or the global. So what you do basically in vBond, in vBond you install a certificate, and the same certificate, because how the certificate works, I hope you guys are aware of, right? So using that vBond IP address or FQDN, you're going to register with the CA, right? CA would sign that certificate and send it to you. You would install that certificate in vBond. And same thing goes to all the components, and through the certificate, that is how they recognize, that is how they authenticate each other. So ultimately, while troubleshooting, if you see that the certificate has expired in particular one device, consider that that device won't communicate with the vBond, and ultimately it is offline. Why? Because authentication, it is not passing that criteria, serves as the first point of authentication. So as soon as you deploy the vBond, all the devices kind of should get not registered, but should get authenticated by this guy. It gives you the go ahead. Okay, you are added, you're authenticated, right? How to do that? We will discuss, we'll do the lab, we'll understand, we'll see how to perform all that one by one. Requires public IP address, as I told, since it is in internet deployed, right? It should have IP address, public IP address, where these guy, all three, should be able to reach, right? And provides NAT traversal as well. In case if we are using, obviously we will be using NAT, so it also provides the NAT traversal. All other components need to know the vBond IP address, as I told, whether it is vSmart or vManage or vEdge, they should know what is the IP address of vBond or fully qualified domain name. They should know, right? Authorizes all control connections. I just now told AAA, authentication authorization. That's what basically it performs. Authorizes all control connections. In whitelist model means insecure model, right? So while now this SD-WAN can be deployed virtually, and when we say virtually means VMware, or can be hardware centric, right? So deployment part we'll discuss. Let's move ahead and understand the vManage. vManage is NMS for SD-WAN, network monitoring system. right? We discussed this can be vmanage can be of single tenant or multi-tenant. Man, you means you can deploy it for a single customer or multiple customers. Just like in Nexus, you have VDC. You can create multiple VDCs, and that those VDCs can be given to multiple, vendors in kind of a shared basis. Single pane of glass, day 0, day 1, day 2 operations. That's what I was talking about earlier. What is a day 0? Designing, implementation, and monitoring. And additionally, troubleshooting. So all those tasks, the activity you would be doing where? In vmanage. Enables centralized provisioning and simplifies changes. So since we talked about day 1, implementation simplifies changes. So if I want to make changes to any VH, right, I don't have to log into the devices here. Rather, I log into the vmanage, create a template, right? And I can create the template device specific. I can create the template all devices specific, right? And push that template and send that template to particular device. That's all. So the change is done. I don't have to plug it, access it, SSH it. Later, if you want to, if you want, it's not like you won't have access to these VHs. You would have access. You can still SSH it, right, for your other operations, but these things can be managed from the way we manage, right? Supports REST API, right? So how to configure it? So it supports REST API, right? Command line interface also through CLI, syslog, SNMP, and netconf. These are kind of the method of how you can use vmanage, how you can configure vmanage. So we'll see different options here. We'll see CLI, we'll see netconf, we'll see the REST API as well. Provides real-time alerting. Since it is also used for the monitoring, it does provide the real-time alerting. And then role-based access control. So this is where basically we can create the users who can access what kind of changes that can be made, all that can be performed in vmanage. We'll discuss it further. In the meantime, let's take a short break and then we'll be back.